Good day, students. We are going to perform an experiment on Hooke's law. The aim of the experiment is to verify Hooke's law. You can see the display. Aim of the experiment is displayed to verify Hooke's law. Now, when we talk about Hooke's law, what is the statement of Hooke's law? Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the extension E of the material is directly proportional to the load or applied force F. Directly proportional means that if the force is doubled, then the extension also doubles. So for performing this experiment and to verify the statement, if extension is directly proportional to the load, let us see what apparatus we are needing to perform this experiment. Let us look at the apparatus now. So this is the apparatus which we are going to use to perform Hooke's law. There is spring, there is meter rule, this is the stand, and these are the weights which we are going to use. So we are going to use 50 grams first, and for us to use 50 grams, this is 50 grams weight. Before I add 50 grams weight, let me look at let me find the length of the spring. So you can see the spring here, and there is the spring starting point starts from 50. It's 50 and it's ending. So let me stand straight to the meter rule so that I avoid parallax error. And then, so the end of the spring is at 33. The end of the spring is 33, and you look, the starting of the spring is 50. So from 50, if you subtract 33, you get 17 centimeter as the length of the spring. From 50, look at the 50 and look at the 33 displayed here, 33. So this is the length of the spring. This length is what you are going to measure using the meter rule, and we got it as 17 centimeter. Let me report it on the tabular column. So when you record it on the tabular column, look at the tabular column for Hooke's law. Serial number, mass / gram, length / centimeter, extension / centimeter. So these are the three variables which we are using to perform this experiment. Now mass, I didn't add any mass for the first one, so it is 0. When I put 0 mass, the length which is shown, which the spring has, the length of the spring is 17. And did it extend? It cannot extend because we did not put any mass, so the extension is 0. The second experiment is we are going to add mass, and let me add 50 gram mass to the spring. So that is how, this is 50 gram mass. When you add it to the spring, let us see if the spring is extending. Yes, let us see if it is extending. So the length is, starting point is 50. Look at the ending point. The ending point is 31. 31. So 50 minus 31. 50 minus 31. So it is 19. 19 centimeter is the extension. When I added 50 grams, my length is now 19 centimeter. So from 17, the spring has extended to 19. So what is the extension? It's 2 centimeter. It has extended. Why did it extend 2 centimeter? Because I added 50 grams mass to the spring. Because of the mass, the spring has extended 2 centimeter. The next one, we will add another 50 grams to it, and so if you look at another 50 grams, when you add, it becomes 50 plus 50 is 100, and then you hang it. And when you hang, you will see that it has extended. Let us see how much the spring has extended. Starting 50, now it is 29. The length of the spring, look at the spring's point, 29. So 50 minus 29, that is what is that? 10 minus 9? 1. 4 minus 2? 21. So when I added another 50 to it, now it is 100 grams. My length is now 21. 17 minus 21. How much has it extended? When I added 100 grams weight, it is the length is 21. So from 21 minus 17 is 4. You do not go and subtract 21 minus 19 because 19 is an extended length. You look at the original length of the spring. The original length of the spring is 17 centimeter. So now the extended length is 21. So how much did the spring extend? 21 minus 17, 4. Now let me add another 50 grams and make it 150. So for 150 grams, you remove the hanger, take another 50 grams, add it, it becomes now how much? It's 150. Hang it. Let the spring not disturb. So I've added 150. Look at this length. Starting 50 and the spring. Go and look at it vertically. 27. I see it is 27. Look at the 27. 50 is the starting point. 27 is the ending point. So 50 minus 27, that is 23. 10 minus 7 is 3. 4 minus 2 is 2. So 23. Note down the length. It's 23. The length of the spring is now 23. From 17 to 23, it has extended. So 23 minus 17 is 6. So it's 6 centimeter extension. The next part, the last part of the experiment, you add another 50 to it, making it 200. So when I added another 50, it became 200. When I added 200 grams, what is the weight? Remove the hanger, add another 50. So it becomes 200 and slowly you hang it. Let it not oscillate so you won't be able to find the reading properly. Now look at that 50 and from 50 now the spring is 25 centimeter. 25 is the ending. 25 is the ending point. So 50 minus 25 gives me 525. So you see, here the starting is 50 and here it was 25. So the length, this whole length is now 25 centimeter is the length. 25 centimeter. So I will write 25 is the length. So what is the extension? 25 minus 17.
8.
8 centimeter is the extension. So we got the extension, we got the mass. You see, as a mass, we added 50 grams. Each time we increased 50 grams. You see the extension from 0, it became 2, then 4, then 6, 8. This is what we saw directly proportional. Means what? As the mass is doubled, the force or the extension also doubled. As the force is doubled, extension also doubled. So we are trying to verify Hooke's law. Now we have looked at the tabular column. Let us transfer the data to a graph to get a clearer picture to verify Hooke's law. So let us draw the graph. To draw the graph, I have already labeled the axis. I have written the scale also. It's 0, 2, 4, 6, 8. So I have from here you can see that this is mass. X-axis is represented. Mass is representing the x-axis. Extension is representing the y-axis. I've written the scale. Extension axis, that is this axis. Extension axis. 2 centimeter is 2 units. You see, 1 centimeter is 1 unit. Each 1 centimeter is 1 unit. And look at the x-axis. That's the mass representing mass. X-axis is being mass is representing x-axis. So mass axis, we have 2 centimeter. 2 centimeter. This is 2 centimeter. 2 centimeter is 50 units. 2 centimeter is 50 units. And here 2 centimeter each. That is 1 centimeter is 1 unit. So totally 2 centimeter is 2 units. We have written that. If you have a confusion, each one is 1 centimeter. I can write here this as 2 centimeter is equal to 2 units. 2 centimeter, 2 units. This is 1 centimeter. If you look at this, this is 1 centimeter. This is 1 centimeter. Totally 2 centimeter. 2 centimeter equal to 2 units. Let us plot the points. 0, 0. That's the origin 0, 0. For 50 grams, it's 2. For 100 grams, it's 4. For 150 grams, it's 6. For 200 grams, it's 8. So that's it. Now, if we draw a straight line connecting all the points, drawn a straight line passing through the origin. So the straight line shows that the force is directly proportional to extension. As the force increases, as the force doubles, extension also doubles. Now, from our display, we saw that after you draw the graph, they are asking us to find the gradient. How do we find the gradient? Once you get a straight line, draw a straight line. Take any 2 points on the straight line. Let us take this point and let us take the 2 points. Let us take 2 points such that we get a big triangle. Now, when we connect, let us connect the 2 points using a straight line like this. So, after we connect it with a straight line, so to find the gradient, we took 2 points on the straight line, we connected with a triangle. This is how we draw the triangle. Now, vertical distance, gradient formula is you find the vertical distance and then you divide it by the horizontal distance. Let us look at the vertical distance. Look at the vertical distance. This point is 8. This point is 2. So the distance is what? 8 minus 2. 8 minus 2. Look at the horizontal distance. 200 and this is 50. 200 minus 50 is what? 150. So 8 minus 2 is 6 over 150. So what is 6 over 150? Divide it and tell me the answer. What is 6 over 150? So 6 over 150 is equal to, this is how we find the gradient. Find the vertical distance divided by horizontal distance. We got the vertical distance. This is 8, this is 2. So 8 minus 2, 6. And this distance is 150. That is 200 minus 50, 150. 6 over 150 is? 0.04. 6 divided by 150 is 0.04. So that is how we find the gradient. So every time we draw a straight line and then we find the, once we get a straight line, we should understand that force is directly proportional to extension and then we find the gradient for it. So whenever force is directly proportional to extension, provided that it is not passing beyond the elastic limit, then we say Hooke's law is verified. So that is about verification of Hooke's law. We have done it. Now let us look at the precautions we are supposed to take for this experiment. Precautions here: avoid parallax error when taking readings on the meter rule. And we try to do that. How do you avoid parallax error? By looking at the meter rule straight, not from a slanting position. Looking at the meter rule straight, vertical with the eye level. Second one, repeat the experiment several times to get an accurate result. Always you should keep this in your mind, that every time you take readings, at least repeat it twice or 3 times so that you can get an accurate result. So this is the end of verification of Hooke's law. So once again, let me go to the previous slide to check the Hooke's law. Once again, Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the extension of the material is directly proportional to the load or the applied force. And the applied force here is the mass. We added the mass. And we saw that as we increase the mass is doubled, extension also doubled. So that's the meaning of directly proportional. So thank you so much. So we have verified Hooke's law.